Progress.
Oh no. Got it. I got it.
Just want to make sure. Okay, thanks everybody for joining us today. We are going to be enjoying a wonderful presentation from our very own Drew. And then after the presentation, stick around. I do have a question I want to ask about brown bags and get your guys' opinion on it. And yeah, so go ahead and take it away, Drew. Thanks.
All right. Well, today we're going to talk about abstractions and errors. I know everybody's super excited. Riveting content, but feel free to interrupt me. Just so you know, I've thoroughly prepared for this by putting these slides together like hours before this meeting. So it should be good. So before we can talk about errors, we need to do some groundwork because we need to make sure that we really understand the concept of abstractions in terms of software. So let's do a little journey and let's figure out what an abstraction really is. Does anybody think they know what an abstraction is offhand? Hedges raised his hand. I saw it.
I mean, just asked, do you think you know? And I think I know, but.
Okay, well, what do you think?
An abstraction is a way, is it specifically in software or in general?
You can do in general or in software, either one.
I'm gonna probably go closer to software. It's a way to create a layer between something that's complex and creating an idea or concept that helps hide that complexity or focus that complexity into something easier to understand.
That's pretty good, Hedgie. That's pretty good. Let's see what the macOS dictionary says, though. The macOS dictionary says it's the process of considering something independently of its association, attributes, and concrete accompaniments. That seems a lot like what Hedges just said. It seems like, you know, it's about hiding these associations and these attributes and these concrete accompaniments. Let's see, what does Wikipedia say? Oh, Wikipedia says it's the creation of an abstract concept, even closer to what Hedgie said, by mirroring common features or attributes of various non-abstract objects or systems of study, or the result of the process of abstraction, because it's always fun to define terms in terms of themselves. So let's go with this idea that abstraction is really the act of creating a new concept and hiding details or attributes away from that concept. We'll go with Hedges' definition. So there's many different types of abstractions, there's many different layers of abstractions, and there's many different tools for creating abstractions. If we look at programming languages are one of the biggest abstractions that we use every day. Right? If we think about the computer, we basically have a programming language. And if we just think about the layers of languages below that, there's basically like assembly and bytecode representation. And like for compiled language, there's intermediate bytecode representations. Then there's like actual binary that's processed by the CPU. And the CPU itself is technically an abstraction as well, right? So this kind of rabbit holes down further and further, and we can see that these abstractions are building on top of each other. So like not only do, you know, functions exist as an abstraction in their own right, but they're also a tool for us to create our own concepts and abstractions. Classes are similar, right? They're an abstraction, but also allow us to create our own concepts and abstractions, methods, modules, structs, etc. Right? All of these are abstractions and also facilitate us creating new abstractions. So given that the term abstractions used across all these different contexts and all these different use cases, it's a pretty overloaded term. So it'd be helpful if we understood maybe at a deeper level what abstractions could mean and what terminology we have to use to be able to communicate clearly about them. So one type of abstraction that exists is this concept of a control abstraction. So this is also known as a procedural transaction abstraction. And this is usually implemented using modules, functions, or methods, right? But we also have, like, conceptually at a lower level, structured programming in general is an example of this. If we look at this example right here, which I yanked off Wikipedia, right, we can see there's a variable called a getting an assignment of this expression of 1 + 2 × 5, right? Well, if we actually look at this and look at the different procedural abstractions in play, we have the addition operator. That's a procedural abstraction. At a lower level, there's a lot more steps going on to do the actual arithmetic of 1 + 2, right? So the addition operator is an abstraction that the language provides to make that easier for us to perform. Same thing with the multiplication operator and the precedence operator and even the assignment operator. So those are all examples of these different layers of abstractions that are control abstractions. And we can also see how we can build those on top of each other, because we could build a function that has a complicated math expression like that inside of it. And that function would also be another layer of abstraction. So the other type of abstractions that are in play are what are called data abstractions. And these are a little fuzzier in the world of software, right? If we go back, like, these are pretty formal and concrete in terms of their concept of the abstraction and their boundaries. But data abstractions are a lot more fluid on this spectrum, right? Where you can have a data abstraction that, hides all these properties of data, or you can have one that only hides a portion of the properties of data and exposes other child properties, or you can have one that hides none, right? And these are all acceptable forms of data abstractions. I think the important thing to take away is just understanding that even when you have, like, no hiding of attributes, like, let's say you defined a struct called address, and that address had like a zip code and a street and, whatever other pieces of attributes, right? Even if you expose all of those attributes publicly as part of the public interface of that address struct, you've still defined a concept of an address. So you're still have done part of the job of defining an abstraction. Okay, it's just a slightly less formal abstraction in terms of hiding the attributes. And that may not be a bad thing in the case of data abstractions. And so that's something to consider. So how do we have these two types basically of abstractions. How do these fit into our different programming paradigms that we use on a regular basis? So we have functional programming and we have object-oriented programming. In terms of functional programming, our data abstractions are completely separate, right? We just have data, we deal with data separately, and we deal with data abstractions around those types of data separately. We have operation abstractions around things like functions in functional programming, and those are completely separate. In the case of object-oriented programming, if you're truly following object-oriented programming, you actually have this merger of the data and operation abstractions into almost a singular concept of abstractions around data and the associated operations with that data. Now, in practice, most object-oriented programming I've actually seen in the real world doesn't actually do true object-oriented programming for the majority of the time. So what you'll see is a mixed bag of kind of what you see in the functional programming world in terms of abstractions. And if you're lucky, you'll see a couple of these, merged data operation abstraction cases. So really, what is the abstraction then? Does anybody want to take a gander of what they think the abstraction is now? No, nobody knows. I thought Hedgie would for sure chime in after his glorious answer the first time.
I'm giving other people the opportunity.
All right, John question marked it. Let's go forth. So maybe if we understand the anatomy of an abstraction, we can actually understand what really the abstraction itself is. So I created this super contrived example. We have a function called add. It takes a number v1 and a number v2, and it returns a number. And inside it just returns v1 plus v2. Super contrived. Okay. So what pieces of this do we think are part of the abstraction? Somebody's got to tell me.
Is it the variables of the function name?
The
The
variables,
parameters?
the
Sorry,
parameters,
the parameters of the function abstract.
yeah, the parameters of the function are definitely part of the abstraction, right?
The name of the function?
The name of the function is another piece of the abstraction. That's true.
The response or the result of the function.
The result of the function, that's also true. There's one more that I see.
The addition operator.
Oh, the addition is the addition operator is definitely an abstraction, but it's an abstraction that's a lower level abstraction. Do you see anything else related to the abstraction at the level of our add function?
Code block.
The types of the parameter.
The types are definitely part of the abstraction.
The fact that it's a function.
The fact that it's a function. Anything else? Everybody gives up.
Said everything.
Is that everything? It's not everything. There's one more piece.
There's nothing.
All right, so the abstractions consist of the
Oh, the
name,
return.
and then they have an interface, and that interface is kind of the signature of the function, right? So we have add, which takes a number, and a number returns a number. So we have, and that's broken down into inputs, like John said, and the return of a number and the types. But there's this last piece, which is this internals, which is the part that's hidden away, right? And that is important because that isn't necessarily part of the abstraction, is it? I mean, it is, but it isn't. Like when you're thinking conceptually about the abstraction, you're not thinking about the implementation. In fact, you're trying to hide the implementation away so that it could theoretically be implemented in a different way. So that's our anatomy of an abstraction. We have a name, an interface, and we have these internals that are hidden away. That's what we've concluded. So again, what is the abstraction then? If those are
Is
the
it the part
parts
you're hiding? Oh, the whole thing.
is it the part we're hiding? No.
It's just a piece of it.
Nobody
Hiding the implementation.
hiding the implementation? No.
Oh, sounded so good, Phil.
I thought so too.
The abstraction is two things. It's the concept and it is the interface. So in our previous example, we had a concept of adding and we had an interface of adding with two numbers and getting back a number. So in many programming languages, we also have protocols and interfaces. We can formalize these things if we want to, but they exist irrespective of whether we choose to formalize them or not, right? The abstraction exists and the concept exists without us ever formalizing. And we also have generics, which allow us to, implement things in even more abstract ways by saying like, hey, we have an addition function that takes, two generic types of the same type and returns a type of that type. So the key is that it's the concept, though. It's this idea of addition, and it's the interface by which we perform that addition, which is the abstraction itself. It's not the internals that we're hiding away. So let's look at another example, right? So here we have this other abstraction, which is a function called get user profile that takes a user ID and returns a user profile. If we look at this, we have this, REST client .get call that's used inside of that function to get back the user profile, and then we return that user profile. What could go wrong with this? Does anybody see what could go wrong with this?
What if
Maybe-
there's an exception when you get?
Oh.
Oh,
So the REST client get could throw a REST client error exception. Man, that would be interesting, wouldn't it? What happens to our abstraction when we do this? What does our abstraction look like? Who's gonna fill in the blanks?
Means you, right?
You could make the return optional.
Well, no, we're trying to fill in blanks here. How are we gonna fill in these blanks?
So you have a name called get user profile. We have,
Okay,
we have an interface as an input of a string user ID, and it will return us a user profile object. And the internals contain a REST client get abstraction.
all right. I like it. Good job. A+ for Ryan Hedges.
Yay!
You could
All right, but is anything else wrong? Does anybody else see what's wrong?
where do you get REST client from?
Oh, yes, that is
Okay, well, never
that is technically a problem, but I left that out just to simplify the example. Yes.
Yeah. It might not accept anything after the user endpoint, like user ID might not be accepted.
That's true. So what happens if that's the case, or what would happen if that was the case? What would you normally, if you make a REST request to something that, doesn't exist or something, what would you normally expect to happen?
A 404.
Error.
500.
Yeah, so you get some sort of error back, right? So,
Whole subject of the talk.
Whoa.
yes. So there's this implicit exception missing. So we need to add this concept of exceptions to our interface. So our abstraction, the interface of our abstraction is not complete without the concept of the exceptions being part of it, or the possible exceptions being part of it. So in this case, we have this theorized possible REST client error that could be, thrown as an exception by calling get. And what actually happens is that, hey, that gets propagated up because we don't do any try catch block handling of that exception here. And so our abstraction of get user profile also throws an exception of REST client error, in turn making us a leaky abstraction, aka a non-holding abstraction. So what does this mean? It means you're leaking details that are supposed to be hidden away on the inside of your abstraction, and you're allowing them to expose to the layers above, which you shouldn't do. Don't do it, people. You heard it from me.
Why would you not want to do that?
Why would you not want to do that? You would not want to leak stuff from the insides, because then you are forcing your consumer of your function, or the consumer of your abstraction, to then not only have to deal with the concepts at your layer of abstraction, but you're forcing them to also have to be aware of and deal with the concepts at lower levels of abstraction. So you're defeating the purpose of your abstraction in the first place, because the whole point of your abstraction is to hide away these lower level complexities and details so that the consumer of your abstraction doesn't have to deal with those things. So if you have a leaky abstraction, even in the case of just exceptions, right? And you expose this REST client exception, the consumer that's saying, hey, get me this user profile, it doesn't know or care about how that user profile is gotten, right? That's the abstraction it's creating. It's hiding away the how of getting that user profile. So when that's pumped up and you all of a sudden get a REST client error, the consumer now has to be aware of the fact that it's being implemented using a REST client, and that REST client error can throw these different possible errors and then handle those different possible errors. Does that answer your question?
It does. Thank you.
Cool. So we learned that exceptions are implicit, and we learned that they promote this idea of leaky abstractions because they make it very easy to have these leaky abstractions. So we learned that exceptions are bad, except for in very exceptional scenarios. So what's the alternative? What do we have in our toolbox that we can use instead? Enter the result type, AKA either, if you're from a background of functional programming languages, which have had this for ages. So the result type is just an abstraction of its own that lets you represent the success or failure of something, right? And in the case of success, it has an associated value. And in the case of failure, it has an associated failure case value. So that could be the error, right? This is very similar to the concept of optional, or maybe, if you're familiar with those from any other programming languages. Those represent the existence or non-existence of a piece of data. And those exist as types to facilitate and help force you to deal with the fact that the data can be there or not be there. The same way result exists to help force you to deal with the fact that the result can be successful or unsuccessful. So generally, these are kind of implemented using enums with associated values if the languages support that. If the languages don't support that, then there's various hacks depending on the different languages to support possible either cases. But basically, you can conceptually think of it as there's an enum with two different cases, an OK case that has the associated value, and an error case that has the associated error value. So what does it look like before and after? If we look like the before, we have this REST client get, which returns this response, but it has this magical implicit REST client error exception that we have no idea that this can be thrown unless we actually go read the code that implements that function, or the authors of the documentation of that function happen to be nice enough to include that detail for us. If not, we'll just get an exception and we'll be like, crap, we got an unhandled exception. But now with results, we can actually see from the signature that it returns a result type of a response or a REST client error. So now we can see explicitly from the result type what the possible error types are. This is huge. Knowing what a function can return and can do is crucial. The type system helps us make sure we handle both the success and failure cases also, so that we don't accidentally forget to be like, oh yeah, this could fail. We need to do something about it. If we want to explicitly be like, I want to do nothing about this and let it blow up, we can do that. We just have to tell it we want to do that. So what do we learn about results? We learned that it solves the implicitness of exceptions, makes it possible to get benefits from the type system to make sure we're handling error cases, and it promotes the concept of held abstractions because we have to formalize the types. All right. These are all sounding like good things, and we should probably all be using results, shouldn't we? So I know what you're all thinking. Especially Corman. But most of you on the engineering side are
Hanging on
thinking,
by a thread here.
yes, I know. But all you on the engineering side are thinking, but if we make sure that these are all held abstractions, they're all true abstractions and they don't leak, man, we got to create a bunch of error types and we got to do a bunch of mapping between different error types and all this crap, right? Well, yes, and you should have been doing it already. Not doing it means that you're propagating internal errors and creating leaky abstractions through your whole damn application. Every single layer that you don't have error handling in like this is just bleeding and leaking abstractions all the way up through your whole app stack. So it doesn't really have to be that hard though. So let's see why not. Well, there's this idea of classifying errors. Well, it's a way of creating an error type that is generic enough that can actually be used in multiple use cases. Like a prime example of this is like an IO error. Let's say that you're creating a bunch of procedural abstractions as functions that interact with the file system. Well, you know, the types of errors that are going to happen with you interacting with the file system are probably going to be basically the same across all those different functions. So you could define an IO error class and you could use that error class across all of those different functions. Hence, you've created a classified error. This is a good way to collapse and limit the amount of error types you have to create. But you do have to think about it. So it's not as simple as like, I don't want to use my brain and I just create a thing and follow copy paste. This is, you do have to think about how you're going to classify errors and if it makes sense to classify them. You also have to think when you're using classified errors, if you use a classified error, you might run into situations where you're like, hey, this classified error has these 6 different cases and 3 of them make sense for me and the other 3 don't. What do? You don't use that classified error because you're lying about your abstraction. That's just as bad, if not worse, than making a leaky abstraction. Do not lie. Don't be liars. So the other concept we have to deal with related to this is we have to deal with abstraction layering or abstraction building. And this is the fundamentals of all of this. This is this idea that we talked about at the very beginning, where we had a programming language, right? And we said there was many layers of abstraction beneath that going all the way down to the CPU. Well, the fundamentals of that is this concept of abstraction building or abstraction layering. And that's that we create new higher level abstractions to simplify things. And beneath that, we have interactions with lower level abstractions. In our little example that we had this get user profile abstraction. And that was interacting with the REST client get abstraction. So that's our layering. We have this layering of get user profiles, this higher level abstraction that interacts with this REST client get, which is lower level abstraction. We're doing it right there. Okay. So what would it look like if we had the exception version of the REST client get function? We would have to catch the exception and we'd have to map it to a result type with an error type matching a layer of get user profile. So that might look something like this. We have a function, we have a try catch. We call the function. If it succeeds, we return an OK of our user profile. If it fails, we get the error, and then we return an error result with the create of get user profile error from the REST client error, right? And that's what that would look like. Not super interesting, not super sexy. What if we had the result version of REST client get? Well, it would look pretty similar. We still have to have this function to create, a get user profile error from a REST client error. We call get, we get back a result, and then we check if that result is okay. And if it's okay, we return an okay of that result. If it's not okay, we get the error out of it. We create the error from the REST client error, and we return a new result, which is an error with that error. So if you close your eyes, you slowly open them, and you blur your vision a little bit, they look almost identical. You still have this basic conditional kind of logic wrapping around and handling the case of success and the case of failure. So again, just not that much fun. So what are we going to do? Well, luckily, result types help us. They provide useful functionality like map error, where we can then simply take and do a REST client get dot map error and give it a function that maps from the REST client error to the get user profile error. And magically, simply, it's all handled for us. It's kind of amazing. So there's got to be more, right? There's got to be more to this. Well, there might be in certain cases, but there's only so many options, really. I mean, there's only a few things you can do with errors in general. What do? We consume them, right? We catch an error and we handle it programmatically. That's one thing we do. We translate them, right? We get an error from a lower level. We translate it into a higher level abstraction error, or we propagate them, right? Where we're taking an error from a lower level and we're letting it propagate up into the worlds above. Well, probably, don't want to be doing that last one too much unless you really know what you're doing, but because you're likely creating your leaky abstraction again. But there are cases where it is correct to do so. But that's it. We're down to 3 things. All we do with errors in general in all of programming is basically 3 things. We either consume, translate, or propagate. So turns out, the result type is aware of this and provides utilities to make doing all of these things easier for us. So in the case of consuming, generally when we consume something and we handle an error, one of the most common things we want to do in that scenario is actually provide a default value in place of the thing that failed. Well, result provides unwrap or. All we have to do is call unwrap or and hand it the default value we want to use, and magically it plugs in the default value. And so we can consume and hide the fact that that thing even is possible to fail from the consumer of our abstraction. We also have translating and nesting lower level errors, right? Guess what? They provide map error, and map error facilitates the ability to do that. So we just give it a nice little function. We also have propagating. Propagating, tactically, this is how you would do it. You just, return a result that has the propagated type, and it works. Yeah, this is not a great example of what you would actually want to do because this is creating a leaky abstraction, but tactically, this is how you would do it. So you might be thinking, doesn't this all sprawl out of control? I got to create all these functions. I got to map all these errors. I got to do all of this stuff. The answer is no. It doesn't sprawl out of control. It sprawls into control because it's a naturally collapsing problem. You can think of it as the base of your pyramid down at the bottom being the core origination of possible errors. And what happens at every layer of abstraction above that is that you are categorizing and grouping those lower level errors into higher level abstractions of errors, or you are consuming them completely, eliminating them. So by the time you work your way up to the top of your application, you've narrowed down and limited those errors to these much higher level of abstraction errors, or eliminated them completely. So it doesn't spread out like a fan, it collapses in. Do you have any questions?
I have one. So let's say what's your strategy for debugging? So let's say at the lowest level, you have some error that you messed up on, right? And then at some point you want to, are you logging that somewhere? Are you passing it back up somehow so you know what happened? What's your strategy for that?
Yeah, so it depends on the error case, the error type and the error case. So there's basically two things that happen. And that's this scenario here of this error handling translate or nest, right? And so in this case, which you basically have, it's still just the mapping process of mapping the error, but the distinction is whether you translate or nest that thing. So your higher level error abstraction. So in the case of like this example, we have this get user profile error, right? That could have a case that is that wraps the child error object, right? And that's the nesting case, right? Where you nest that particular child error object in it. And so you can do that n layers deep, right? And as long as you are using a consistent methodology for doing that, you can have functionality on your error types in your base error class that can facilitate, you know, traversing that entire tree of those nested.
So you're making a deeply nested error, and you're not flattening it out as you're passing it up.
Yeah, those are the two options. You can flatten it out, which is the translate case, or you can nest it, right?
Gotcha.
And so, but whether you do which one depends on the scenarios and the types of errors that you are dealing with normally, right?
Okay.
With the sprawl stuff, I find when I'm trying to figure out what I need to do or what I need to build or what I need to capture for errors, I sometimes try and imagine, like, what do I want another developer to have to think about? Do I want them to think about these issues or these concerns, or do I want to be a nice person and think for them and make decisions for them? In some scenarios, I can't make those decisions. I won't know. Therefore, I might do something where I'm translating or wrapping or nesting, like whatever the solution is, to let them make those decisions. But if I can, I'm hopefully consuming that error and doing something where I'm returning a default one. And then that makes it so that, you know, the person doesn't have to, whoever is doing using that code or having to modify that code later on, they don't have to think about things.
Yeah.
We all
Yeah.
hate
You know, interpret
Yeah.
it so
I think
much, overdo it.
Yeah, I think one of the things that's hard for people to get in the practice of is thinking about the concept of the abstraction itself. Like, what is the abstraction, right? And like we talked about at the beginning, the concept, like it's the concept combined with the interface, right? And so like, if we're taking this example of like get user profile, the whole point of get user profile is to abstract away how it is gotten, right? We're saying the consumer of this function doesn't need to know nor care how this user profile is actually obtained, right? That's the whole point of get user profile existing as a thing. So if we then say, cool, well, from a function calling standpoint, we just call get user profile, we give it a user ID. We don't care how that's implemented behind the scenes as a consumer. Our error object needs to be in alignment with that same concept, right? It needs to be in alignment with the idea of hiding how it is gotten, right? And so in this case, I would argue we would want to take and actually do a translation of whatever the rest client error cases are to more meaningful errors cases that apply to this particular abstraction layer, right? And so that could be something as generic as like, you know, like an unknown failure where you have an associated nested, you know, error kind of thing in some cases, or it could be very specific things like, you know, what do we do when, you know, we get an unauthorized access response from the API, right? What do we communicate back to the person trying to get the user profile? And that depends on what do we think that consumer needs to do with that thing? What should they be able to programmatically handle? Is the other thing to consider, right? Is like, are the cases that you define are generally going to be things that you care about them programmatically handling. When you collapse everything down to a specific case, like let's say you were to use like a generic error class, like exists, you know, in JavaScript or TypeScript or whatever. When you use that, you're making it effectively impossible for the consumer to programmatically handle those errors, because those, all they know is that it's an error, but they don't know what type of error it is. And there might be some associated string data with that error type, but that is only theoretically useful for potentially displaying to the end user in some fashion. It's not useful for programmatically analyzing it and doing some operation. And so those are like the types of things that you need to be thinking about when you're defining your errors and thinking about what cases should exist in your error types.
Should you, let's say you're using a framework or a language that has error types,
Mhm.
maybe just like an exception type or something like that, a very base one. Should you try and use that, or should you create error objects that better reflect your interface?
So like in TypeScript, for example, let's say we took TypeScript as like a tangible example. What we should do in TypeScript is we should use base exceptions to create our own exceptions. And then in our result objects, we should be having results typed with our custom exceptions, right?
So you do want to inherit. It's not
The-
just creating a new object that says, "Oh, this has the, you know, these properties on it." You
Yeah,
want to that you conform to maybe the language's exception.
yeah. The reason being isn't specific to results, right? The reason being generally that you want to do that is so that you can translate between those two worlds, right? So when you have a exception happen in the world, you're gonna want to be able to translate that into a result type. And when you have a result, in certain cases, you're going to want to be able to translate that back into an exception type, because there are other concepts and other things in the languages that are built around exceptions. So like, for example, when you start talking about async await operations in TypeScript, right? Or promises and how promises deal with failures, you know, those are cases where it could make a lot more sense to convert from a result type to an exception and then use the promise chain to handle the error cases, you know, in the promise chain in a similar way to the result type. So that's the benefit of sharing that kind of as the base exception, or base error class uses the exception as a base, is that it facilitates you being able to easily go back and forth between those two worlds.
Is this a result pattern, or I forgot the other terminology used? I know that some languages let you define the exceptions that are thrown by maybe a function,
Mm-hmm.
and some languages don't have that functionality. Is that, if I have a language that I'm using that lets me define this throws these errors,
Mm-hmm.
is that the same, or is that a different pattern, a pattern that maybe should be avoided?
Yeah, so it's not the same. It is a pattern that is better than the implicit exception pattern that we see in things like TypeScript or JavaScript. But like if you look at Swift, for example, like most of these languages that allow you to specify that the function throws an exception still doesn't specify which exceptions are possibly thrown. It just tells you that an exception is possibly thrown in the most cases. So you're in this like approaching a slightly less implicit world where you at least know that, hey, I'm interacting with a function that could throw. I don't know what it could throw, but I at least know it could throw, right? And then in the theoretical world of we have a language that actually does let us formalize what types of exceptions can be thrown, then we're in an explicit world of, so in terms of the explicit versus implicit nature of them, it's equivalent to the result type in that context of being explicit versus implicit. However, the result type being a return type also facilitates performing additional operations from like a functional programming standpoint that you can't do with in terms of the exception handling case. So it's still a better option to opt for the result type versus the scenario of I have a special language that facilitates exception typing.
You're talking about like method chaining and stuff?
Yeah.
Cool, thank you.
Mm-hmm. Cool. Any other questions? Cool. All right.
All right, thank you, Drew, for presenting us about abstractions and errors. As I saw somebody do preemptively, round of applause, round of applause.
Hey, it's Corman.
Corman.
I thought he was at the TBC.
No such luck.
He could be.
That background.
Now the internet's ticket.